So let's have a range, maximum height and time of flight for complementary angles. So let us say, as we already discussed earlier, range for theta is 2u square sine theta cos theta by g. Let us have a range for 90 degree minus theta. So sine 90 minus theta is cos 90 minus theta is sine theta. So I can write again 2u square sine theta cos theta divided by g. So we can write here range for theta is equal to range for 90 degree minus theta. Example, range for 1 degree is equal to range for 89 degree. Range for 15 degree is equal to range for 75 degree. Let us have height. Height for theta is u square sine square theta by g. Height for 90 degree minus theta is u square sine square 90 minus theta is cos square theta by 2g. Now if I add this, h of theta plus h of 90 degree minus theta is equal to, this becomes u square divided by 2g. Now let us have h of theta multiplied by h of 90 degree minus theta. So this becomes u square into sine square theta divided by 2g into 2g. Let us take the square root of this. So this becomes u square into this becomes sine square theta is sine theta into cos theta by 2g is 2 root over. So if I write like this, 4 into h of theta into h of 90 degree minus theta root over is 4 into u square into sine theta cos theta divided by 2g. So this becomes 2. So this becomes 2u square sine theta cos theta by g. So I can write this is nothing but r of theta is equal to r of 90 degree minus theta. So I can write here r of theta equal to r of 90 degree minus theta is equal to 4 of h theta into h 90 degree minus theta. T of theta is equal to 2u sine theta by g. T of 90 degree minus theta is equal to 2u cos theta by g. So I multiply this t of theta into t of 90 degree minus theta is equal to 2 into 2, that becomes 4 u square sine theta cos theta by g into g. So here I can write 2 by g common, 2u square sine theta cos theta by g. So this becomes 2 by g of r of theta or 2 by g of r of 90 degree minus theta. So I can write here t of theta into t of 90 degree minus theta is equal to 2 by g of r theta, 2 by g of r. So this is a question related to these ranges and maximum height and for complementary angles that we discussed. So this is a shell burst on contact with the ground and the fragments fly in all directions with speeds up to 39.2 meter per second. Show that a man 78.4 meter away is in danger for root 2 seconds. So we will have 78.4 is the range. So I will write 78.4 is u square sine 2 theta divided by g 9.8, or I can write u square is speed is given as 39.2 square into sine 2 theta divided by 9.8. When I solve this, I'll get sine 2 theta is half, or that implies 2 theta is 30 degree or 150 degree, or theta is 15 degree or 75 degree. Now ranges for 15 degree and 75 degree are same, but the time of flights for 15 degree and 75 degree will not be the same. So he is saying man 78.4 meter away is in danger for 4 root 2 seconds. So let us calculate that. T is equal to T2 minus T1, that is I can write 2u sine 75 by g minus 2u sine 15 by g. So I can write 2 into 39.2 by 9.8. This is sine 75 degree minus sine 15 degree. So this is 2 sine 75 plus 15 by 2 and sine 75 minus 15 by 2. So this becomes all is 16. This is 4 into 2, 8 into 16. So this is sine 75, 90, 45 degree into this becomes sine 30 degree. So I will write here 16 into 1 by root 2 into 1 by 2. So this becomes 8. So this is 8 root 2 by 2. I can write this is 4 root 2 seconds. So this is the way how we calculate that the man is away in danger for 4 root 2 seconds. So this is 2 unique times for which projectile is at same height. So let us take a projectile. Let us take these 2 points, A point and B point, which are at a height h. So there are 2 points A and B which are at the same height. So let us calculate the times. So h is equal to u sine theta to t minus half gt square, or I can write half gt square minus u sine theta into t plus h is equal to 0, or t square minus 2u sine theta by g into t plus 2h by g equal to 0. So this is a quadratic equation, 2 roots. So t1 and t2. T1 time is from O to A, T2 time is O to A to B. So 2 roots, so I can write T1 plus T2 is minus B by A, 2u sine theta by G, which is nothing but T, and T1 T2 is 2h by G. So I need to calculate time taken from A to B. So T2 minus T1 is time taken from A to B. So I can write T2 minus T1 whole square is equal to T1 plus T2 whole square minus 4T1 T2. So T1 plus T2 whole square is 4u square sine square theta by g square minus this becomes 4 into 2, 8h by g. So that I can write here T2 minus T1 is 4u square sine square theta by g square minus 8h by g whole square root. And you can calculate this distance, that is x. You can calculate x is the distance of AB, which is nothing but u cos theta into time AB, and time of AB is nothing but, here I can write this is time of A to B. So this is u cos theta into time of AB is 4u square sin square theta by g square. Let us have a radius of curvature for an oblique projection. So radius of curvature means at any instant, if the particle is given the freedom, now the particle is trying to say, I want to make a circle of radius of curvature rho. So here I mention radius of curvature is rho. So the particle is able to make that circle is or not, that is not our concern. So when we talk about radius of curvature for an oblique projection, we say at that instant of time, the particle is trying to say that he wants to make a circle of radius of curvature rho. So radius of curvature rho is, here I will write velocity of particle at that instant whole square divided by acceleration or component of acceleration perpendicular to the velocity vector at that instant. So let us go with an example at highest point. At highest point, so the particle is projected with velocity u at an angle theta at highest point. At highest point, velocity is the horizontal component only, and the acceleration vector is exactly perpendicular. So here radius of curvature at highest point will be u cos theta square by g. Now let us take another example. The particle is projected with a speed u, angle theta. Let us find out at this point, P point, where the particle is making at an angle theta by 2. Let us find the radius of curvature. So let the velocity at point be v. So horizontal component of velocity of a projectile remains same. So v cos theta by 2 equals to u cos theta, or v is equals to u cos theta divided by cos theta by 2. So now we will find the acceleration or component of acceleration. Acceleration acting at this point is vertically downwards. So this g and v are not perpendicular. So I will take the components here. This is theta by 2, so this will be theta by 2. So this will be g cos theta by 2. So here I will write rho at point P, velocity at that square by component is g cos theta by 2. So v square becomes u square cos square theta divided by this becomes cos square cos cube. So this is again we will find equation of trajectory of an oblique projectile in terms of range. So y equals to, I can write x tan theta minus gx square so I take x tan theta to be common. So this x and x cancels out. So this becomes x tan theta 1 minus gx by, here I can write 2u square, tan theta can be written as sin theta by cos theta. So 1 cos theta cancel, sin theta cos theta. So here I can again write x tan theta minus 1 by x by 2u square sin theta cos theta divided by g. So this I can write y is equal to x tan theta into 1 minus, this is range. Now a ball is thrown from ground level so as to just clear a wall 4 meter high at a distance of 4 meter and falls at a distance of 14 meter from the wall. Find the magnitude and direction of the velocity of the ball. So we'll have, I'll use that equation, y equals to x tan theta into 1 minus x by r. If you look carefully, range is here 14 meter plus 4 meter is 18 meter. So xy becomes 4 is equal to 4 tan theta into 1 minus 4 by 18. So this becomes 2, 9. So this cancels out. 1 is equal to tan theta into 9 by 7 by 9, or tan theta is equal to 9 by 7. So 9 by 7, so this is 130. So sin theta becomes 9 by 130 root over, cos theta becomes 7 by 130 root over. So I'll use range, square sin theta cos theta by g. Range is 18, is 2 into u square. Sin theta becomes 9 by 130, so 9 by 130, and here becomes 7 by 130 divided by 10. So this becomes 180 is 2u square into 9 by, this is 13 into root 10, so 13 into 10 into 7 by 10. Okay. Now you can calculate from here the velocity of u. Now a particle is thrown over a triangle from one end of a horizontal base and after grazing the vertex falls on the other end of the base. If alpha and beta be the base angles and theta be the angle of projection, prove that tan theta is equal to tan alpha plus beta, tan beta. So we'll have, like here, this is a projectile. I take any point here. This is projection, theta. Let this point be x and y. Obviously this is x. Now obviously this will be r minus x. And this is y. This is alpha. This is beta. So from here I can write tan alpha is y by x. Tan beta is equal to y divided by r minus x. So add this, tan alpha plus tan beta is equal to y by x. I take all LCM and I write y common, I take r minus x plus x by x into r minus x. So this one cancels. So this becomes yr by x into r minus x. Now we know from the equation of trajectory in terms of range. So this x tan theta into r minus x by r. So here I can write tan theta is equal to yr by x into r minus x, which is same as this. So tan alpha plus tan beta is equal to tan theta is proved. Now this is a new section of projectile relative motion between two projectiles or motion of one projectile as seen from another projectile. So since these two projectiles are under the influence of gravity and the gravity magnitude as well as direction are same, so A relative is g vector minus g vector becomes 0. That means there is no relative acceleration. That means no relative acceleration means, since we are talking about projectile is a two-dimensional, so ax is 0 and we have ay is 0. Let us have a method 1. So ax is 0 means dvx by dt is 0 or vx is equal to a constant. Let it be k1. Similarly, here also I can write dvy by dt is 0, vy is equal to a constant, let it be k2. So again I can write here dx by dt is equal to constant k1 or x is equal to k1 into t. And here also I can again write dy by dt is equal to k2 or y is equal to k2 into t. So y by x is equal to k2 by k1 into t by t. So this is, let it be k. So y is equal to kx. Equation of a straight line. That means a projectile 2 being seen by 1 will be a straight line, or projectile 1 as seen by projectile 2 will be a straight line because there is no relative acceleration. Now let us have like u1x is equal to u1 cos alpha 1, u2x is equal to u2 cos alpha 2, u1y is equal to u1 sin alpha 1 or u2y is equal to u2 sin alpha 2, and a relative is 0. So I can write u1 to x is u1x minus u2x. So this is u1 cos alpha 1 minus u2 cos alpha 2, and u1 to y will be u1 sin alpha 1 minus u2 sin alpha 2. So the system will be something like this. This is u1 to, let this angle be theta. So this is u1 to x, so this is u1 to y, and a relative is 0. So tan theta is u1 to y by u1 to x. Now if u1 cos alpha 1 is equal to u2 cos alpha 2, then the relative motion will be in vertical direction. Now if u1 sin alpha 1 is equal to u2 sin alpha 2, then the relative motion will be in horizontal direction. Now condition of collision of two projectiles. So I say I take a height. Let this height be h1. Let this height be h2. Let this be point A, point B, projectile thrown u1. Let this be alpha 1. Let this be u2, alpha 2. Now these two projectiles will collide in air. So I can write two projectiles will collide in air if relative motion is along AB or BA. So I can write here u of 1, 2 along x is u1 cos alpha 1 plus u2 cos alpha 2, opposite directions, and u1 to y along is u1 sin alpha 1 minus u2 sin alpha 2, and tan theta will be h2 minus h1 divided by, let this distance be s, and time will be AB divided by net u1 to mod. So net UAB divided by u1 to mod will be u1 to along x square plus u1 to along y whole square root. If you can say particles are at same level, that is h1 is equal to h2, then u1 sin alpha 1 must be equals to u2 sin alpha 2. That means u1 to along y must be equals to 0. Now a horizontal projectile is fired from a tower B. The shooter fires his gun from point A at an angle of 30 degrees. Determine the muzzle speed of the bullet if it hits the projectile at C. So here we'll have the horizontal distance is 20 is VA cos 30 into T, and the vertical distance is y is 10 minus 1.8, that is 8.2. So I can say here 8.2 is VA sin 30 into T minus half GT square. Now here I can write VA as, or I can directly write in this form, y is equal to x tan theta minus gx square. From this equation VA is 20 by cos 30 into T. So y is equal to VA sin 30 into T minus half GT square. So this becomes VA is 20 tan theta minus half GT square. Y is 8.2. 8.2 into 20 tan theta is tan 30 degree minus half GT square. So I can calculate here half GT square is equal to 20 tan theta minus 8.2, or T square is 2 into, or T is equal to, I can directly write 2 into 20 tan theta minus 8.2 by G root over. Once you calculate T, you can calculate VA is 20 by cos 30 into T. Now a projectile aimed at a mark which is in the horizontal plane through the point of projection falls a centimeter short of it when elevation is alpha and goes b centimeter far when elevation is beta. Assuming speed of projection to be same in all cases, find the proper angle of projection. So the diagram is like this. This is the correct range, and when it is thrown at an angle alpha, it falls as short of A. When it is thrown at an angle of beta, it is and this one will be theta. So first I write range, correct range, u square sine 2 theta divided by g. Now it falls a centimeter short, so u square sine 2 theta by g minus a is equal to u square sine 2 alpha divided by g. It falls b centimeter more. Let this be equation 1. U square sine 2 theta by g plus b is equal to u square sine 2 beta divided by g. Equation 2. So multiply equation 1 into b and I will multiply equation 2 by a. So this becomes u square sine 2 theta by g into a into b to b. This is minus ab. Then I will multiply with the a plus u square sine 2 theta by g into a. This is plus ab equals to, here I multiply with b, u square sine 2 alpha divided by g into b, plus here I will multiply with a, u square sine 2 beta divided by g into a. So this ab and ab cancels out. So here I can take u square sine 2 theta divided by g into a plus b. So here also I can take common as u square by g I can take common. So b sine 2 alpha plus a sine 2 beta. You can keep it like this. U square by g cancels out. So here I can write sine 2 theta is b sine 2 alpha plus a sine 2 beta divided by a plus b. Now again I take here to show here. So this 2 theta, so I can write theta is half of sine inverse b sine 2 alpha plus a sine 2 beta divided by a plus b. The correct angle of elevation.